All right. Well, I'm Drew Porter,
I'm Stephen Smith.
and we're talking about physical security. We're from Bishop Fox, and let's just get right into it. All right. This is our agenda. We just have going to be going over a few things with physical security, and then a few fixes that you can do. All right, demo time. Let's just start this off right away. Now, how many of you guys knew that there are about 36 million installed home security or office security systems in the U.S.? All right. I see one person. Good. They read the abstract. This is good. So there are about 36 million home security devices. Now, how many of you guys actually have home security devices? All right. Quite a few of you. That's good. I have one myself. I have two myself, actually, because I'm paranoid. But it doesn't really matter, your paranoia level. So how many of you guys set it before you left and came to this conference? How many of you guys set it before you leave for the grocery store or such? All right. So not many of you guys actually use your alarm systems that you have installed.
Why don't you just talk to me?
That's all right. Yeah. Clearly we don't need to give this talk because no one uses it. All right. Well, let's say you left for some conference in Vegas or something, right? And you alarmed your house. Now, with that, if I'm someone that knows you have something important within your house or your office, and I know you're going to be leaving for this security conference, and you're probably not going to pick up your phone because you're drinking way too much at this security conference, I'm going to know I have a large window of opportunity, but I only need less than 30 minutes. So the first thing I run into as the intruder is your doors and windows. These are simple points of entry. Every house has them, for the most part, I think. My house does. So when I'm looking at this, I see you have an alarm system because I see your little sensor right on your window. I realize your window can prop open, though. And when I prop your window open, you have this annoying thing go off. Oh, we can let it longer. I like that sound. Yeah. Okay. It's like nails on chalkboards. And what you have, I'm going to move this chair. I'm walking around it like an interrogation or something. So what we have now is we have this sensor that makes this lovely noise whenever we do it. I should do it towards the mic. But whenever we do it, so we're opening up this window and it goes off. But what if we open up the window and your sensor doesn't go off? What if your sensor is now defeated by magic? There you go. Someone can have that. Because you don't need that part anymore. Because you have everything that you need in your pocket. And all it took was $5 for a magnet. So now where I'm inside your house, I'm pretty proud of myself. And I didn't set off any alarms, but I noticed a few things. First thing I noticed is I'm not smoking. So who's got a lighter, actually? Anyone have a lighter I could use? Could I use it? Awesome. Come see me afterwards. Ooh, fancy lighter, too. Nice. Let's see if I can operate this. Okay. Smart enough to operate the lighter. So I'm lighting a smoke, and I'm not trying to thwart your motion detectors that I'm seeing by covering everything in smoke. I actually, if we can get our demo working, just give us a second. Technical difficulties, live demos. Here.
Here's what happened.
Clearly, your sensors are already broken, so I'm good. They're not working that well. Thanks. Let's see. Yeah, so our batteries actually ran out for this sensor, but good thing we bring DC power benches, right? Just happened to be in our backpack. So, or not. That's all right. Here, actually, can we maybe turn down those lights? It shouldn't affect the sensor, but it might. Now, this sensor has been abused quite often, so let's see if we can get it to, let me see if I have the sensor. Oh, yep, there we go. Nope. Okay. Doesn't want to work. That's okay. We got a video for this. Oh, we have a video somewhere. Did you already have it on your computer? Loaded?
Nope. Praying to demo gods.
So we thought our demos were going to work.
We tried this like 50 times in the hotel. Promise.
All right. That's our other video, just in case it doesn't work. So I'll talk about this quickly while it's going through this little video. We have our motion detector. This is what it looks like taken apart. Oh, it's not on the screen. Why do I even talk? There we go. We have our motion detector, and this is what it looks like turned on. Now, I'm going to activate it by turning on the power supply. This is just a proximity detector, what we'd see standard in a house. So let me flip this thing on. Video self, flip on. All right. Okay. So the light blinks, and that lets us know that this particular sensor is on. I wave my hand around it, and I see, okay, oh, there you go, it trips. Now, when it trips, it's because it senses motion. It's a infrared, so it sees heat. But what happens when we decide we want to trip it and apply a special frequency of light, which just so happens to be infrared or near infrared? Now, with this, when we have it tripped, I can light something like a lighter, and it will instantly turn off. In the video, I'm supposed to be doing this. Clearly, I don't. There we go. Or I just like hearing myself talk in the video. There we go. Your sensor is now disabled for 3 seconds. It will turn back on, but then we can then apply the strong light wave for near or infrared light towards it, and I can move around. As long as I have that, I can move around your house. Clearly, I'm going to be smoking a lot, or I can show you another device that we got working. All right, so now I am past your house, or past your front door, and I'm past your motion detectors. What do we have now? Well, now we have your keypad. Keypads operate with a few different ways. The one that we're going to be looking at is cellular. How do I make sure that I never send a trip to any emergency services? Let's say I don't care about any of these detectors, and I just break in your house and I trip everything. How can I capture something that you can't see? Well, it's cellular. Some of us know how to build rogue base stations. Not that people do that for fun, like at conferences, but you do it. And now we notice that these keypads, your neighbors, yours, if you're testing it, your neighbors might have connected, but you notice that these keypads actually start jumping onto your network, and there's particular settings that we must have. So I'll start our cellular network. You want to bring that towards me? All right. I have our cellular network on. I'll turn on our keypad now that uses a quad band receiver. So it should turn on. We should hear a beep.
Not that beep.
The person that turned off his cell phone as I bring down the cover was the smart one. All right. Now, this keypad is looking for a signal. It will go to pretty much any carrier you want it to go. But we found that if you pretend to be, I'll just say mobile country code 310 and mobile network code 410, you guys can look up what that is. These keypads seem to like to attach to that, which makes it easy for us. Oh. Well. Other things like to attach to this, even though it's in a Faraday cage too, apparently. Or that could have been my other device, actually. Oh, no, that might be this device. Okay. Yeah, we'll show you through the video just to make sure that we're safe. As you can see, clearly demo gods were not that kind to us today, but that's fine. It happens. Okay, so I'll give the intro part to this. What we want to see is we have our cellular keypad, and it's connected to our cellular tower. Now, this is done in my home lab, and my home lab is a Faraday cage. So make sure you do all that testing inside a Faraday cage. It's very important. Carriers don't like you to be them, and people don't like it when they can't call 911. So you don't want to mess around with that, actually, in all seriousness. So we'll go over to our item, and I shortened down the screen. Actually, yeah, so we see this guy right here. In the very bottom one, we have 3 test devices that I have hooked up to it. And then we have a keypad. 310, 640, 1 is the start of the ISME, which all you guys know what an ISME is. This shows that our keypad will now automatically connect every time that they want, or that it turns on, or that we drive our base station by it, which is also shown here. Let me bottom blur, keypad blur. Oh. Or not. Okay. Well, it's shown. What you guys can't see in the Faraday cage is this is our keypad that we have hooked up. And if you turn off your base station and turn it on, your keypad will keep on reconnecting. So now I have the ability to control what alerts get sent out and what alerts get dropped. So your main part of your security system is alerting a third party, or you, depending on how you have it set up. I just set off every sensor in your house, and nothing went out. Your house is literally hopeless because it can't send anything. What you're doing now is forcing the keypad to connect. But what if we can send commands to the keypad? What if I don't want that annoying alarm to go off anymore? What if I want to make sure that my team, if I'm doing a physical security assessment for an office, doesn't have to worry about where all your sensors are? They can trip it and I can disable it for them. That's when this talk or this topic becomes, a little scary. But we talk about the fixes for it. So, despite some of our technical difficulties, we did have a backup. But that is how you defeat a home security system. And it's fairly simple. Took us 11 minutes with technical difficulties. All right, we'll go in the main part of our talk now, where we go more into detail of all these sensors and why these sensors were able to be defeated, as well as why this keypad is able to connect. Well, who are we? I'm Drew Porter, like I said. I'm a senior security analyst for Bishop Fox, and I run a project called the DustNet. Some of you guys might have read about it. And shameless plug, rootthebox.com, CTF for younger generation.
Yeah, my name's Steven Smith. I'm also a senior security analyst at Bishop Fox. And second shameless plug to rootthebox.com. I'm a big part of that. I help run it. So, yeah.
Awesome. So in this talk, what are we really focusing on? Well, we're focusing on home and office security systems, but what is it? We want the door and window sensors. We want the motion sensors. And then we want the keypads, the brains of everything. This combines a typical home security system, a typical office security system. We're not covering cameras or, keypads, RFID. We already have another talk about that, actually. But the cameras and whatnot have been discussed before. And we don't need to go over and beat you guys with a dead horse about this is how you break into a camera system, this is how you turn off the cameras.
Just to be clear, when he says keypads, he means getting into a door.
Yeah, like RFID, and then you type in your 6 or 10-digit password.
These keypads are the thing controlling everything that we're breaking. So background.
We'll give you a little bit of background of everything, and then we'll start going into everything in detail. There is another part to this. Our QA person said we needed more. Who?
Olivia Newton?
Yeah, there we go. She said that our slides needed more her. We're hackers. We don't understand cultural references or anything. So this is to make our QA person happy in the crowd right now. You're welcome. All right.
So some of the basics, we've got all the sensors, and there are two main reasons to use a sensor, and that's to deter the intruders and to alert the authorities so that they can be caught and then arrested and your things are safe or broken or whatever. And as I mentioned before, the three basic parts are the door and window sensors, and the door and window sensors are very similar. They're most likely going to be this magnetic sensor. And then you have the motion detectors, and then you have your keypad, which is kind of like the centralized system that holds everything together. And that's what makes up your basic system. You spend a lot more money, you can get fancy systems, but they
run off the same principles. So.
Right. But this is your three main parts.
So, some quick facts about physical security. The first one is that people, like in other physical security items, are being told these things like this can be broken, but other people that develop these don't want to hear it right now. Or they just are in this sense of bliss, and they say, hey, it doesn't matter, not too many people know about it, we're good. And that's why we're trying to bring this forward to you guys, so that these devices that are supposed to be security systems that protect our families can be bettered.
Also, I apologize, the slides got messed up here. We were having some troubles earlier. But behind that picture is a clock, because it's these security systems have a 5 to 20 year life cycle. So it's hard for security companies to update their systems because they don't feel like they need to. And that's what we're bringing to light, is that a lot of these basic systems are broken easily. So their 20-year life cycle should turn into maybe a year or two.
Then we have cost. Devices are developed to be low cost so that people can buy them and they can be mass produced, and a lot of people will buy them because they make money not basically off the unit itself, but on other items that they sell with the unit.
And then we have the final part, which is the most important part to take from this, is that a lot of companies are asking for physical security assessments now, outside of their network assessments and stuff like that. People are wanting their office and stuff tested. And so this is man breaking in, clearly.
So our basic office setup, how does this work? Our basic office setup has the three components. Now, we first look at the motion detectors, and they're placed throughout it. All right? So if you're doing an assessment, this is where some motion detectors could be within your office. Then we have door and window sensors. Our door and window sensors are basically our first alert sensors, unless someone stayed in and then they're moving. These are placed on every entrance that's external. Most of the time you don't see places that have internal entry points or internal doors that have open sensors on them. But external access. And then it all ties in to our keypad, the brains of the system, as we're calling it. And this allows you to report out. This allows you to go and, disable one device if you're in there and you know, hey, I have like a demo going and it's using balloons and it keeps on tripping off the motion detector. You can disable that one device. You can call for help there. Optional items are like panic buttons that all talk to this. Now we have the type of sensors and how they work. And this is where we go into detail. This is, more of the why we're able to do this. Why does this work for many sensors? How can this work with different technologies, even if they are deployed there?
Yeah, so we'll start with the outside door and window sensors. So these are the most basic ones, as was shown on the demo. They work with magnets, and basically the magnet, when the second part of it, which is over there somewhere, is put together, it completes the circuit, and it's good and it's safe. But when the door's open and it breaks the circuit, then we have the alarm going off. And this works the same way with the sensors that are attached to the keypad as well. But instead of a loud noise, it hits the keypad and it sends the alert out to the security company, and they call the police. We also have this ball, we have this ball sensor. So basically, when the door is closed, this little ball is pushed down, and when you open the door, the ball falls out, or it falls down to the bottom, and it trips the sensor. And the way you get past these, with the magnets, you just place a huge magnet on it, and sorry. Yeah. Sorry about that. All right. So, in terms of defeating them, we have the magnets, and by placing a much larger magnet than this, because it has to go through the door as well. But if you place it up near the sensor, then when you open the door, it'll complete the circuit still, because you have a secondary magnet touching it as well. And for the ball, you can use a sheet of metal or a sheet of plastic if you have to get through metal detectors at some office building beforehand, and you basically slide it through the door and you hold the pressure of the ball while you're opening the door. You get past it that easily. Now for the motion sensors, we have different types, but they all work on the same principle, the ultrasonic, and this is the microwave and the tomographic motion detector, and then the ones that we have, which is the most common one, it's the cheapest one, is the passive infrared, or PIR. And this works by detecting temperature changes. And so the room is room temperature, and when someone walks into the room, it starts to change the temperature of the room itself. So it trips the motion detector. And I can go to the next one. Then there's the dual tech sensors, which most likely, one of them is most likely going to be the passive infrared. Other one's going to be another cheap one like microwave. But they both have to trip to cause an alert, which makes it makes it easy to break still, because even though there's two different technologies, both of them have to go off. And to defeat these, there's a couple different methods. There's the lighter method, which, if we could have shown that in person, it'd been awesome. But there's, to get to the motion detector as well, you can hold a piece of cardboard up in front of yourself, and it won't be able to detect the temperature change from you because you're holding up this piece of cardboard or styrofoam. And you can walk right up to the sensor and then trip it or disable it by using a lighter, or if you have this picture is it's an infrared light that looks like a little bomb, I guess you can consider it. You slide it under the door, and then it goes off, and it kind of floods all the motion sensors at the same time, and will disable all of them. It's very easy to make too.
This one is for dual technology. So if you have microwave and heat, what you have to do is you can't just slide a stick underneath there and move it around. You get these little hand warmers, warm them up, Put them on your metal rod that you use or something like that. Slide it underneath the door, move it around, and you can get in. Now, this type of attack that you would do is not one that you'd want to do if it's connected to the security system. It's usually for like maid entrance doors with shared offices. They'll have these so that you don't have to swipe your RFID badge or whatnot going in or going out. So they have the motion detectors that just let you unlock the door. So you just pop it in there, move it around, and you're good to go. Now, the big one is keypads. They're the brains of the alarm system. That's where everything connects to, and it reports out. Now, the monitoring service that you choose, they operate similarly. You can have it report directly to you as well. Some people don't like paying for monitoring services. Some people don't like don't want other monitoring services know that they actually have an alarm in their house. So they have it report back to them, to their cell phone, or to some type of pager device if you're still back in the 90s. There's many different types of data connections: landline, broadband, and cellular. This is how it all connects out. And these devices, most of them are landline, and all these new devices are going into cellular. With that allows us to take over them remotely. But we'll discuss how you can take over landline ones as well. And they're kind of the holy grail, actually, of the whole security system. You can trip alarms, and that doesn't matter because you can then send it commands. And we'll talk about what commands you can send or what commands you should send. So defeating these. Now, with cellular, the most common way people think about defeating it is jammers, right? You can jam it. Now, that doesn't really help you unless you actually know the keypad code itself. Now, with knowing the keypad code, you could just walk in anyway and then disarm it. So it's sort of like an old approach to it. A few people have done it before, but it's not the best approach. So that's why we wanted to do like a cellular base station or an ISMI catcher. That topic's been around, or it's been hot in both this conference and other conferences with, I forget his name, releasing it like 3 or 4 years ago and showing how you can build it for a fairly low cost. So his system, you can build for around $800. This system itself with the USRP N210 with just a daughter board is about $2,400 to $2,700. So that attack's kind of expensive. It's not a lighter. You can't go to AMPM and pick up a ISMI catcher. At least the AMPMs around my house, I don't pick up ISMI catchers. And you also, you can't go and it's not like finding a strong magnet. So you do have that cost barrier that you run into. There are solutions that are coming out, like the Blade RF. They're porting, what we're using is Open BTS actually. They're porting that to this, and this costs about $400. So now your barrier to entry is a lot lower to be able to intercept traffic from keypads. And then with landlines, there's really, what we found if we don't want to do it destructively is we can make a device that's a little black box that has, you have jacks that go out in it, but what it does is it actually applies power. It has a tap is the other part. The cable that comes out is a tap that connects to a landline, and it applies power to this POTS cable. And with that, these keypads will trip if you cut them or if you unplug them. The keypad waits anywhere from 1 second to 5 seconds, and then it will automatically send an alarm. And it won't be able to send it out, but it will be able to alert people, which is enough to deter a lot of people. But if you have this tap and you put it on the cable and you unplug it, the reader sees no voltage differences. It's within its tolerance of time that allows for the voltage to drop and go back and applied for it to be, not tripped. And the infrared and the this tap, we actually have designs for that are on the internet that you guys can download if you wanted to see how we built these devices. Now, we're coming towards the fixes of everything. For door and windows, fixes for door and windows are actually quite difficult. And it's because they rely on magnetics or magnetic fields. If we can take this device, apply a magnetic field, it's never going to trip. So until there's a new type of device that is developed for it, then we're kind of screwed on that one. Same with these ball ones. We can slide thin sheets of aluminum and they get stayed up, and then you can apply tape on it so you don't always have to be there or someone has to hold it, and they'll never trip. But for motion sensors, we do have a few fixes. We have better sensors that are more accurate, that are harder to defeat, or use greater technology that aren't easily thwarted. The ICs in them don't get confused when you apply some source of infrared to it, and it not only shuts down, but sends a forced restart and does not send that problem to the keypad. Some sensors, if you just flood them with IR, which is a common attack, will automatically send a trip to that keypad. The family of sensors, these two families, they come in standalone and networked. This is a networked version that attaches to a keypad. It's two different families of sensors. Will not send that panic to the keypad. And all it sends is a, hey, I restarted and I'm turned on. And the keypad just sees that as, okay, this is good. The other fix that you have for it is location. Sensors that are put in a corner are terrible when you have drop ceilings, because I'll just have someone that's obviously much skinnier than I am climb up in that ceiling and cover that sensor with a piece of cardboard. Or I'll have them move your sensor slightly so it no longer looks at the doorway that I want to enter in. Right? We see that we can't thwart your sensor, or we can't bypass it by doing our IR flood, or not flood, but our IR reset. We see that these location-based devices, if it's right above the door and your door on the other side has a drop ceiling and then you have one, I'll just move it up a few degrees. I'll put a piece of cardboard over it so I don't have to touch it, leave fingerprints or anything, which is what you want. You want to leave, when you're doing a physical assessment, as you guys know, you want to leave minimal tracks, minimal forensic evidence towards it. And then keypads. Keypads are not that hard to fix, actually. They're the part that can make the system the most secure. The attack that we showed works on cellular keypads, but we can't send commands to every single keypad out on the market. This is because they're not using something as simple as like the Heinz AT commands. Though they will accept it, they won't pass it, and they don't use those as, hey, this is how we disable it. Some of them do use secure connections. So that's good. Others use dual technologies for reporting. So you have a landline and you have a cellular, or you have a cellular and you have broadband. These are ways that we can make it harder for an attacker to get in to your office, to your home, something like that. Makes it harder for an assessment team to go out and get into your important documents. Then we have reporting services with secure protocols, sort of like with the ACT commands. But this actually comes down to the reporting service itself. When it sends something, is it sending it in the clear and then its response is secure? Or is it sending both secure and response secure? You'd be surprised how many keypads actually are only one way secure. All the commands to it are secure, but all the off commands aren't secure. So then we can start reversing it, which is what we move towards. And then we have technology inside the keypads. My keypad for my home security system says that it has CDMA and it has GSM for reporting services. So if I don't have access to one of those technologies, the other one will take over. If GSM gets jammed, CDMA will automatically fail over. CDMA gets jammed, CDMA will fail over to GSM. If the towers go down and they're blazing on fire, one of those technologies will still be up. One of the carriers will still be up. In the US, we have 4 main carriers. One of those will still be up. Unfortunately, with the 3 keypads that we really were looking at that seem to have common technologies and multiple different families of keypads, they only had one type of tech in there. And that tech was GSM, which made it really simple for us. If it was just CDMA, we could have had a rogue base station for CDMA. And the GSM, what they're using is they're using what's known as phase 2 or phase 2 plus, part of the 3GPP spec, which allows us to have the device connect to us successfully because the device has to authenticate to us, but we don't have to authenticate to the device. And this is like that because you want to have all these services available no matter what your coverage area looks like, right? T-Mobile by my house is near existent for 3G. Nothing is out there. 4G is a joke, but I still have Edge and I still have GPRS. I still have those technologies, so you have to have the lowest technology in these devices if they're used for security. So I'll let you cover up the backup plan.
Backup plans are pretty simple. We have guard dogs, guns, maybe some rocket launchers.
It just depends, how hardcore you want to go with this. But yeah, dogs, guns, your viewpoint. We're not trying to make a political statement here. It's just they're good backup plans for physical security. If I was doing a physical assessment to an office and some security guard had a dog, well, that would terrify me a little bit. If he had a dog and had a gun pointed at me, I'd feel a little bit more uncomfortable. If he had a rocket launcher, I'd be like, I'm clearly in the wrong building right now. So we did do a lot of research in this, and we have a lot of the low-level information, but there are some items that we haven't done research that maybe other presenters or attendees like you could do research on. Key fobs, those panic buttons, really awesome to look at. Wish we could have. We haven't looked at it yet. Glass break sensors, we looked a little bit at those, but there's ways to disable them that we weren't able to really verify. There's like theories, and we couldn't verify it, or the theories that we came up didn't work. Reporting services, back-end protocols. This is some of those security services actually send their commands through a secure channel. We weren't able to break those secure channels, or actually we spent, I think, like 10 minutes looking at it, and we're like, okay, they use secure channels. Good. Next, let's look for one that doesn't. And we found that, okay, a lot of sensors still don't use secure channels because they're so far behind, 5 to 20 years, as Steven said earlier. And then we have other wireless systems. Wireless security systems are a hot thing, and you don't have to drill holes anymore. You don't have to run cables, run power through every sensor. The sensor's cool, but you have to drill a hole, and then you have to drill a hole so you can run the cables up, and then you have to run it through your attic. Living in Arizona, I don't want to spend time in my attic because it's really, really warm. When I say really warm, it's like I have a thermometer up there, and it's like, it's 180 degrees, and my wife's like, can you get something in the attic? And I'm like, the thermometer says no. And I was like, okay. So these wireless systems operate mostly in this 400 band, or 415 to 434. It's an unlicensed band. Or freely available to use in certain, parameters applied. And these things are ripe for just attacking. We did take a look at these, but we didn't have enough time to come up with any research that we would feel comfortable displaying to you guys. We'd come up with theories on how it worked and show like a tiny, tiny proof of concept that only works in a very specific case. We didn't want to do that. We wanted to show you guys solid items that we knew that worked. Though clearly our demos failed, so good thing we didn't show you that small, might work type of thing. But these devices now with SDRs are extremely easily attacked. You can just pop up your new radio, view the modulation, view what data it sends, and then you can repeat that. So,
yeah, it's good to know also that having two technologies per point of entry is usually a good thing too, like the dual authentication type thing. So in terms of the glass break sensors, we would have really tested this more, but we didn't have a bunch of windows to go break.
Yeah.
One of the tests we could have done was, like if you hold a pillow up to it and you break it, then sometimes the frequency that it's listening for won't be the same like threshold that goes over or under it. But using dual technologies and stuff is always good.
Yeah, wired and wireless. That's what I have in my home security system. That's what I recommend in yours. But Your wife doesn't get too happy when you break windows. I'm doing it for research, I promise, hon. She's like, it doesn't matter.
So if you remember two things from this talk, it's that 36 million homes are potentially vulnerable to any number of these attacks, and you don't necessarily need to be vulnerable to all of them, but you most likely will be, because a lot of these systems use very cheap pieces of hardware, and if you can take over the keypad, that it's kind of like a backup plan on top of taking over the whole system, so that if you do end up tripping a sensor, it doesn't matter anyway because the keypad's there. But the second thing is more awareness is needed. All these companies feel that they're safe to sell these systems, and they should probably, look into them, maybe update them a little bit, and go on their way from, selling $100 systems for, maybe $110. Get something more in there.
Right. All right. We have about 5 minutes left for Q&A, and that's what we wanted. So even starting late, we're still able to go on time. Is there anyone that has any questions? Yes, sir. Oh, like a heartbeat. Yeah. So heartbeats are actually quite interesting. We found that some systems either have one heartbeat that checks every few hours. So it does a heartbeat and then it will stop and won't do a heartbeat for another few hours. So you can change your interception technique and only intercept during that time, right before it's about to do its heartbeat. You do it 5 minutes, you cut off your cellular system, and then you go and it does its heartbeat, and then you can do it again. You could pass through data if you had a more commercialized system, but you really don't need to do that. It's just timed. We did find one particular family of sensors, or one reporting service actually, takes 30 days. So heartbeat, 30 days, and then a heartbeat again. And when I was told that, I was amazed. I was just like, this can't be. And sure enough, it is. So you have those windows. If they reported a heartbeat every so often, quicker, that would be great for us, but it would cost a lot on the cellular side, and they don't want to pay more. Right. Yeah. Well, on the landline, that is a thing. We've seen faster heartbeats on landlines. Yes.
Can you address the subject of technician codes being left in commonly deployed home and office services?
Yeah. So actually, we had at the old place I used to work at, we had what I learned to be, what the security system called master codes, and they're meant for testing, which is what a technician code is for. How is that addressed? That's just addressed by better training, more thoroughness by the technician themselves. Finding those technician codes, you might be able to do it, but you're going to have to reverse. We didn't reverse these sensors because that means you have physical access to it, and that also means that you are now doing something physically destructive towards that sensor, which is not what we wanted. We wanted all covert entries or covert methods of entry to get past these security systems. Does that address your question? Yeah, we didn't reverse it, so we have no fine detail that I would feel comfortable saying. We have theories about it, and we could talk about the theories about, after this talk, but not anything.
If my alarm guy comes to work on my system, he doesn't need my code. He uses his own.
Right. Well, you might get that checked out, because when my first security system was installed, the technician actually has no access, and they require you to be there. So you might be able to get those removed. Yes, sir.
I was a little confused by the keypad. Most keypads are hardwired.
They can be, yes. So those control panels have another computer in there, and they're used to communicate, right, to the sensors, and then also they have a back end to communicate via landline or a cellular computer, right?
So as a follow-up question to that, I didn't understand how you triggered the control panel to home to a different carrier. How did you trick
So you actually just overpower the signal. We pretend to be like AT&T or something like that. We overpower the AT&T signal, and these devices will jump onto it. That's how it is. It's just built into the 3GPP spec on how cellular devices work. Yeah, your hand's been up for a little while. Not very hard. I think a wrench would do pretty good if you had the technician in front of you. But actually, how would you do it? Like social engineering? Oh, yeah. So you could do like a keylogger, right? If you have, like most credit card skimming systems will have a touchpad over the touchpad or under the touchpad. You could also have that, and his technician codes will be in there. The service providers that allow you to actually like remotely disable it, the ones that we saw actually use the secure protocols. So they're not just sending basic, AT commands or something like that, or a text message to your keypad, which some of these actually respond to text messages. Yes, sir. Right. Right. Instead of just so you're using data channel instead of circuit switch channel. That's what you're saying. It does have a connection onto the network, but if you have a signal that is stronger than the other one, it's sort of like when you're going from tower to tower, right? You're jumping to another tower because it has a stronger signal at that time, for the most part. When you're doing that, that same principle applies to these chips that they're using, or at least the chips that we saw. Do you understand what I'm saying? So you have a data connection, and then you make it so that data connection is now, you sort of do, when you're overpowering it, the noise floor is higher, so you can't get past it, or your data, or your frequency, or the signal is now jammed essentially, but it sees your tower, and it will jump to your tower. So it does have to jump off their tower first for some time, and then jump onto yours. Yes, sir. Yes, it will, and that's we did talk about that some sensors or a lot of sensors will actually trigger a fault. But these particular sensors that we have up here, we notice that they actually don't trigger a fault, and that's what we found interesting about it. Is there's two families of sensors that allow you to actually go disable them they just reset, and it doesn't trip the keypad. And that was the most interesting part about that. It's not just like you're flooding it and it would trip, because we did that with a lot of sensors. But we did find two families that didn't do that. We're actually not giving out any vendor names. Yes, sir. Well, I'm actually, I'm out of time, and I want to be respectful for the next speaker. If you have questions, Stephen and I will be in the back. Stephen will actually be able to give you more details when it comes to like these motion detectors, if you want to ask him more, and the actual door sensors. So if you have questions, we'll be in the back. Thank you for coming.